Okay, now these are the ones I forgot to give you earlier as far as the works from section 5. I just hadn't finished, and now I realized that I hadn't given you any additional ones, so unfortunately for you, I have remembered that, and therefore I'm going to do it. It's not a huge amount, so we're going to start on problem number 29. And 29 is, it's kind of like we have similar problems in section 4, where they give you either radius, diameter, volume, or surface area, and you have to figure out the others. So 29, they give you the radius. So the radius is equal to 6 inches. So just like with two-dimensional objects, you just double the radius to get the diameter. And we're dealing with a, I guess, a sphere. Yeah, sphere. So we have two equations. We have the volume is equal to 4/3 pi r cubed, and we have the surface area is 4 pi r squared. So the first thing we do is calculate the volume. So we have 4/3 pi times r cubed. And we're going to leave this in terms of pi, so we're just going to multiply all the numbers together except pi. So we'll have 6 cubed times 4 divided by 3, and we get 288. So the volume is 288 pi. And the area, and we got to remember the units, which is inches cubed. And then we have the area, which is 4 pi r squared. Again, we're going to keep the pi by itself, so we don't have a decimal number. And the radius is 6 inches. So we square that. So 6 squared times 4 is 144. So we have 144 times pi, and the units are inches squared. So this is 36. 36 times 4 is 144. We still have the pi. Okay, now problem number 32. We are given the diameter. So that's pretty easy. So we're given the diameter is 10. Is it 10 or 40? Sorry, 40. And the units are feet. 40 feet. So the diameter is twice the radius. The radius is half the diameter. So we just take 40 divided by 2, which is 20. So we get 20 feet. Same equations now, nothing different. 4/3, not 3/4, 4/3 pi r 20 feet cubed. So 20 cubed is a big number. 8,000 times 4 divided by 3, and we get 10,066. But that, if we want to keep it as a fraction, we would multiply the numbers in this top, which would give us 32,000. 32,000 thirds. We get the pi, and we have the units. So that's the volume. Surface area is 4 pi r squared. So 20 squared is 400. 400 times 4 is 1,600. So we have 1,600 pi. The units are squared units, feet squared. Okay, problem 35. Hopefully they give us something other than radius and diameter. So that one they give us the surface area. So the surface area is given as 4 pi meters squared. So remember, the surface area is 4 pi r squared. So what we're going to do is, if you solve for, well, we know S is this, 4 pi meters squared. So what we get is 4 pi r squared, which is the formula based on radius, is equal to the actual surface area, which is 4 pi meters squared. Well, you divide both sides by 4 pi, and you get 1 times r squared, which is r squared, and you get 1 again, so you get 1 meters squared is equal to the radius squared, and you take the square root of r squared, which is just r. And so you take the square root of 1 times the square root of the meter squared, and square root of 1 is 1. So you get 1 meter. Because you square the square root of the square is just the number, so you get 1 meter. So the radius is 1 meter. The diameter, of course, is twice, is 2r, so you get 2 meters. And then we can finally calculate the volume, which is 4/3 pi r cubed. So we have 4 divided by 3 times pi times the radius, which is 1 meter. We cube that. And so we just end up with 1 cubed, which is 1. 1 meter cubed is 1 meter cubed. 1 meter quantity cubed is 1 meter cubed. So we get 4/3 pi meters cubed. Okay, so that's how those work. If we were given the volume, we'd back calculate the radius, and then we could double that to get the volume, and then we double to get the diameter, and then we would use the formula for surface area given the radius to do double. Okay, 38. Volume or surface area. In order to determine the amount of leather it would take to manufacture a basketball, would you need to use volume or surface area? So what we're talking about is the outside, the skin of the basketball, basically. So it's a surface situation. And actually, let's do, well, let's look at 37 too. So while we're doing it, we'll do 37 and 38. So the 37 says, in order to determine the amount of liquid in a spherical tank, what amount the liquid a spherical tank will hold would you need to use volume or surface area? Well, that's not a surface thing. That's a inside thing. So it involves the inside. What's inside of that? So since it's inside, basically that means that we're talking about the volume. And 38 is the outside of the basketball. The inside is just air. So the outside is leather, so that's going to be surface area. Okay. The next one. Let me write that down so I'll make sure I assign it to you. 37 and 38. Okay. 41. Cost to fill a spherical tank. So this is like the carpet example, but instead of laying carpet, which is area, which again is flat, that was in section 4. Here we're dealing with volume. So if a spherical 2-meter tank in diameter can be filled with liquid for $300, find the cost to fill the tank, so each diameter. Okay, so what are we given? We're given that it takes 2 meters. You might be tempted to do this. 2-meter tank costs $300, right? So you might set that equal to 6 and have that as your proportion. But that's incorrect because the diameter is not telling us how much volume we have. It's telling us just the diameter, but we can calculate the volume. So really what we have to do in this case is we have to do volume of a sphere, which is 4/3 pi r 1 cubed. So that's the initial radius. And then you'd have 4/3 pi r2 cubed. So that's the volume of the first one. This is the volume of the second one. Well, you see these cancel out. So those you can divide by those terms and they'll drop out. So what we end up with is r1 cubed over, we could call it $1, and then r2 cubed over $2. So this is the cost per volume. Right, the other way around, I guess. If you to the reciprocal of this, you'd have dollars per volume. But it doesn't matter which. You can have them on the top or the bottom, just as long as you're consistent. So what we have in this case is we have the radius. Well, actually, they have diameter, but the ratio of diameter is the same as the ratio diameter. So we can use 2. We can divide everything by 2, or we can just use the numbers. So it's going to be 2 meters cubed is to $300, as 6 meters quantity cubed is to X. So if we solve for X, well, again, with these ratios, you can move this, the denominator to the numerator up here. You can move this from the denominator here to the numerator. You can move that from the, you can just flip these things around. You can't go this way, but you can go diagonally. So if I move this up here, it's there. Now it's in the numerator. On the left-hand side, I have 6 meters cubed. And then I move it down to the denominator over there. And this one I move up, so it has to actually go up to the top. And of course, we would expect the number to be greater for the larger diameter, so that this ratio has to be greater than 1, which it is. So here you have 6 cubed, which is a reasonably big number, so I'm going to use my calculator to make sure I get a, let's think, 36 is 6 squared times 6 is probably like 228 or something like that. 216. Okay. So it's so what we have is 216 meters cubed divided by 8 meters cubed. So these are the volumes. These are the diameters. Well, they're not actually the volumes. The volumes would be times 4/3 pi r cubed. So they have the units of volumes, but they end up canceling out anyway. The units cancel out. And so the final answer is dollars, which you want anyway. So if we take the ratio of 216 to 8, so 216 divided by 8 is 27. So you have 27 times the volume for the 6 whatever units these are, 6 meters. So the radius is, the diameter is 3 times as much, the radius is 3 times as much. You take 3 cubed is 27. That's where the 27 comes from. So you take 27 times 300, and you get $8,100 for that. Now, the other way of doing it is you could calculate a cost per volume. So what is the cost per volume? It's the cost divided by the volume for that particular case, which would be 4/3 pi r cubed. So we get 300 divided by 4/3 pi times r, which is, the radius is actually 1 meter. So the diameter was 2. So we get 300 divided by 4 times 3 divided by pi divided by 1 cubed, which is 1. And what we end up with is, so the cost dollars per cubic meter is going to be 71.62. $71.62 per cubic meter. So then what you could do is you could calculate the volume for the second case, which would be 4/3 pi r2 squared. R is half the diameter, so the radius would be 3 meters cubed, 4/3 pi r cubed. So you take 4 divided by 3 times pi times 3 to the 3rd power, and I will end up with 113.1 meters cubed. So then the cost, dollars, is going to be equal to the dollars per meters cubed times meters cubed, cost per volume times the volume. So we have $71.62 per meter cubed times 113.1 meters cubed. The meters cubes cancel out, because one's in the denominator, one's in the numerator. We just end up with dollars. 71.62 times 113.1 and we get $8,100 for the cost, which should be exactly equal to what we got here, which it is. Of course, this one's, it looks like we have about the same number of steps, but the left-hand one is certainly a lot easier because you don't have to deal with 4/3 pi for one thing. And you can kind of do it in one step. Okay, so that's 41. Then we have 45 as the next assigned problem. Each of the following figures has a volume is indicated. Find the value of x. Okay, so this is one of these cases that we just use the volume to come up with some algebraic expression and then solve for x. So we have this. This is 6. This side's 4. This side is x. We know the volume is equal to 60. We also know the volume is equal to the 3 sides. So it's a rectangular parallelepiped. So the volume is going to be equal to x times 4 times 6, the 3 dimensions. So x is equal to 60 divided by 24. And that is equal to 60 divided by 24 is 2.5. So the unknown dimension, which is the height of this thing, is 2.5. 2.5 times 6 times 4 gives you 60. Okay, we have another problem like this, except we're using a right circular cone. We're told the volume of the right circular cone is 245 pi. We're given that the height is equal to 15. What is x? Well, what is the volume of a right circular cone? Well, I don't remember, so I have to look it up. It's equal to 1/3 pi r squared h. So x is r, basically. So yeah, we call it x because that's what they call it in the problem. So we really get 1/3 pi x squared h. So we can plug the numbers in. What we know the volume is 245 pi. And we have 1/3 pi x squared times h, which is 15. So we got to solve for x, but really first we have to solve for x squared. So the pi's are going to cancel out because you can divide both sides by pi. Then what we'll get is we get 245 times 3, because this is in the numerator, so it goes over to the denominator on the other side. We'll divide by 15. Divide by 15 and make that go to the other side. And that's going to be equal to x squared. So let's see what x squared is equal to. 245 times 3 divided by 15. 49. So 49 is x squared, so x is equal to the square root of x squared, which is equal to the square root of 49, and the square root of 49 is 7. It's actually plus or minus 7, technically speaking, but we only use the positive term because it's a object, and so the negative one makes no sense as far as this particular problem is concerned. So that is x. I think we have, let's see, 2 more problems. So I'm just going to keep going instead of creating a new video. 51. Volume of the sphere. A plane intersects the sphere to form a circle as shown in the figure. If the area of the circle formed by the intersection is 576 pi inches squared, what is the volume of the sphere? Okay. So what you should notice there is that they do give you the distance from the center to this intersection point. So what we really have is we have the circle, and then we have from the center of the circle down to center of this circle down to the center of the sphere is 7 inches. So what can we do? Well, let's see, what is it, from this information, what we're looking for, we have the area of this circle here will allow us to figure out what this radius is. And then if we take from the center to here, this is the radius of this circle, and then this, so we'll call it R sub C, and then this one will be the radius of the sphere. And you can see it's a right triangle right there. So once we know this, 7 and this, we can use the Pythagorean theorem to figure out the radius of the sphere. So that's the procedure. So we know the area of a circle is pi r of the circle squared. And the area is given to be 576 pi inches squared. So the radius of the circle squared is equal to this divided by pi, which is 576 inches squared. Therefore, the radius of the circle is the square root of 576 times the square root of inches squared. So we get, what's the square root of 576? It's 24. So we have 24 inches. And now what we have is this right triangle. It consists of 7 inches this direction, 24 inches this direction, which was the circle, and then our hypotenuse. So this is 7 inches. This is the circle, which is 24 inches. And this is one of our special Pythagorean triples. So if we solve for this, if you take 24 squared plus 7 squared, it's going to end up being 25. Is that really true? Well, let's see. Square root 24 squared plus 7 squared. 24 squared is 576 plus 7 squared, which is 49. That gives you 625. Square root of 625 is 25. So it was. So that is the radius of the sphere. And they ask, what is the volume of the sphere? So now that we have the radius of the sphere, we can calculate the volume of the sphere. The volume of the sphere is 4/3 pi r cubed, which is, we want to use this radius that we were given out here, 25. So the volume is 4/3 pi times 25 inches quantity cubed. So 25 to the third power is 15,625 times 4 is 62,500. We'll just leave it as a fraction, so it's 62,500 divided by 3 pi inches cubed. So that's the volume. So basically what we did is we looked at this two-dimensional circle. We knew this area, so we could calculate the radius of the circle. Then we said, if we want to find the radius of the sphere, we just have to use the Pythagorean theorem with this right triangle. We could then calculate the radius of the sphere, and once we knew the radius of the sphere, we could use the equation for the volume of the sphere. And then the last problem is perimeter of a square. Suppose the diameter of the circle shown is 8 inches. What is the perimeter of the inscribed square ABCD? And it turns out that, this actually just involves area, so I'm not sure why it's in this chapter, but so there's a square. Let's inscribe a circle. Or the circle is inscribed in this square is inscribed in the circle. This may not be exactly right, so not match up. There we go. Pretty darn close. Okay, so what it says is that the diameter here is 8 inches. And it said, what is the perimeter of the inscribed square? Well, if we know this distance from here to here, so let's see if there's anything else we can figure out. Well, it looks like if you go from the center here to there, that's the radius. So that's also 8 inches. What we're trying to do is see if we can create a right triangle of some sort. So this is also 8. Let's see, what else do we know? Well, one thing, it looks like this is an equilateral triangle. Or, equilateral triangle, not equilateral, isosceles triangle, because it's symmetric. So we know these two have to be the same length. So we would know that x squared plus x squared is equal to 8 squared. So what I'm talking about is this triangle right here. This length would equal that length because, is that true? I'm going to stop for just a second so I can think about this for a minute without. Okay, yeah, it is an equilateral triangle, isosceles triangle, because this distance from here to here would be the same as the distance there to there, and that distance is the same as that distance. So they're equal to each other. So what we get is 2x squared is equal to 8 squared. X squared is equal to, 8 squared is 64, divided by 2 is 32. And so then you take the square root, you get x is equal to what? Well, 32 is equal to 16 times 2. So we take the square root, you'll get the square root of 16, which is 4, times the square root of 2, which is the second term. So that's x. So since that's that distance, the perimeter is just going to be this distance times 8, because you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to multiply that by 8. So the perimeter is going to be equal to 8 times that value of x, which is 4 times the square root of 2, which is 32 times the square root of 2. Units are going to be equal to inches, because that's what was given in the problem. Well, they say the answer is 16 times the square root of 2, so let me see what I did wrong here. Oh, it's because the diameter is 8, so the radius is 4. So I have to divide everything by 2. So this is 4 from here to here, 4 from there to there. So this is 4, 4. So we get 4 squared, 4 squared. So we have 8. 16 divided by 2 is 8. 8 is equal to 4 times 2. When you take the square root of those, you get the square root of 4, which is 2. So you get 2 times the square root of 2. And then we multiply it by 8. Actually, multiply this by 8. So we get 8 times 2 times the square root of 2, which is 8 times 2 is 16. So you get 16 times the square root of 2. So that is the answer.